Hi, in this tutorial session we are going to explain how to find Fourier transform for a rectangular pulse signal. So let's just sketch the rectangular pulse signal. That's the time axis, that's the vertical axis, x of t, and let's assume that the rectangular pulse starts from -2 up to +2, and the height is equal 3, and 0 before -2, 0 after +2. So it could be expressed as x of t is equal to 3 when the time is greater than or equal to -2 and less than +2, and 0 otherwise. This function can be expressed in a different way. We can say x of t is equal 3 when the absolute value of t less than 2, 0 otherwise. Another third expression for the same signal, simply you can say it's equal to the rectangular pulse t over 4. What is 4? 4, it's the width of this function. It's from -2 to 2, it means equal 4. That is 4. So we have 3 expressions for the same rectangular pulse. What's required? Determine the Fourier transform of x of t. To find x of omega, which is the Fourier transform of any function, you integrate the function from -infinity to +infinity, x of t times e to the power of -j omega t dt. So this function is divided into 3 parts, from -infinity to -2, and from -2 to 2, and from 2 to +infinity. So if you do this integration into 3 parts, you have -infinity to -2, the same function, plus from -2 to +2, plus the integration from +2 to +infinity. But as you see from the graph, it's 0 on the left and 0 to the right, so it's 0 here, 0 here. So it means you don't have to find this integration. So you'll find in the middle, it's defined from -2 to +2. What is the function from -2 to 2? It's a constant value equal to 3. So x of t is equal to 3 times e to the power of -j omega t dt. To find the integration of this one will be 3 outside the integration, and to integrate from -2 to +2, e to the power of -j omega t dt. We know that the integration of e to the power of -at dt is equal to e to the power of -at over -a. So we'll do the same thing where a here is equal to j omega. So the answer will be 3 and e to the power of -at divided by -a, and one time will be -2 up to +2. If you want to get rid of this negative sign in front of a, so all what's supposed to do, you just get rid of the negative, and the price you're going to pay, you change the limit. Instead of -2 to +2, you change the limits of integration. -2 will be in the top, +2 on the bottom, and you still have e minus at, the same. Now start substitute. You have 3 over a, and be e minus, substitute by -2 for t, -2 times -8 will be +2a, minus e to the power of -2a. So that's the answer. But now we know our a is equal to j omega. So it would be 3 over j omega e to the power 2 j omega minus e minus 2 j omega. So it's equal 3 over j omega and e to the power j 2 omega minus e to the power of minus j 2 omega. That's the answer, but we still can reduce this expression. We know that sine theta is equal to e to the power of j theta minus e to the power of minus j theta divided by 2j. So e to the power of j theta minus e to the power of minus j theta would be equal to 2j times sine theta. I'm going to apply this formula here. So equal 3 over j omega, and I will replace this by the equivalent according to this expression. So we'll just write here, it's equal to 2j times sine theta. Theta in this case is equal to omega. J cancel j. 2 times 3 is equal 6 over omega sine 2 omega. So it's equal to 6 sine 2 omega. We always like, if you have sine theta, we like to divide by the same angle. We won't write this expression, sine theta over theta. So if you divide here by 2 omega, you change, don't forget the omega here. If you divide by 2 omega, you got to multiply by 2 omega, not to change anything, right? Okay, so keep this as it is, don't touch it. So you have 6 over omega times 2 omega times sine 2 omega over 2 omega. Omega cancel, and you will have 2 times 6 is equal to 12. So, and you have 12 times sine 2 omega over 2 omega. We like to express this function as a function of omega. It's already, so the answer would be the Fourier transform of the signal x of omega is equal to 12 sine 2 omega over 2 omega. That would be the final answer. Let's assume it's required to find the line spectra of this signal. First, we need to sketch the relationship between the frequency omega and the magnitude of the x of omega. So what's x of omega? X of omega is the Fourier transform of the signal x of t. What's the difference between both? X of t, the original signal, it's a function of time. X omega, after we did Fourier transform, is function of omega, the frequency. So that's the value of frequency transform. Transform signal from time domain to frequency domain, so you can make study and analysis for the signal in frequency domain. How can you find the magnitude? Okay, you will say that's omega. Make a table. That's omega, and then you see the function x of omega for different values. You will have negative and positive. 0 will be in the middle of the table, and then you got positive and negative. Just will take some values here for omega. At 0, we know from calculus that sine theta over theta when theta approach 0 is equal 1. And we have something like that, sine 2 omega over 2 omega when omega is equal 0. It would be similar to this expression. So the value of this one would be equal 1 multiplied by 12, then you got 12. Now we'll start to increase the value of omega. You can pick values. For example, let's say, what is the value when the theta, you can call theta to omega in this case. If you want theta, for example, to be equal to pi over 2. So what is the value when theta equal pi over 2? And what's the corresponding value of omega? If theta is equal pi over 2, which is equal to omega, it means we are trying to find the value of the function when omega is equal pi over 4. So right here, pi over 4, and we know the corresponding theta is equal pi over 2. Well, sine pi over 2 is equal to what? Is equal to 1. All right. So now we have the value of the x transform, x of omega at omega equal to pi over, omega equal pi over 4. It's equal to sine pi over 2 over pi over 2 times 12. Let me write just the expression. I'm writing the same expression here. 12 sine pi over 2 divided by pi over 2. We already found this value is equal to 1. So we have 12 times 1 divided by pi over 2. So it will be equal to 24 over pi. So you write here 24 over pi. Let's move to if theta is equal to pi over 2. Pi. If theta equal pi, and theta we know is equal to omega, means we're looking when omega is equal pi over 2. So you put in the table omega is equal pi over 2, which will make theta is equal to pi. So the value of x of omega will be equal to 12 sine theta, which is pi, divided by pi. Sine pi is equal to 0. So 0 over anything is 0, it will be equal to 0. And you can go ahead and move every pi over 4. And if you, now I will just let you do that. If you have pi over 2 plus pi over 4, that will be equal to 3 pi over 4. Okay, so when you have 3 pi over 4, omega equal 3 pi over 4. So what is the value of theta? 3 pi over 4 times 2, because theta is equal to 2 times omega. That will be equal to 3 pi over 2. And now we find the value of x omega is equal to 12 times sine the angle, which is equal 3 pi over 2 divided by the angle 3 pi over 2. 12 times sine 3 pi over 2 is like sine 270, so it will be equal to -1 divided by 3 pi over 2 will be negative, and will be equal, that 73 by 12 is equal 4. 2 will go up, be 8, so it will be -8 over pi. And you have the expression -8 over pi. If you move another pi over 4, so you will get equal to, now it's just 3 pi over 4, you add another pi over 4, so you get 4 pi over 4 equal pi. All right, so you are here at pi. If omega is equal pi, if omega is equal pi, so what is the value of theta? Theta is equal to omega 2 times pi. What's sine 2 pi? Sine 2 pi is equal to 0. So you'll go back again, you have 0. Well, and you can continue to do the same process I did. What about the negative part? It's really fantastic to know this fact. The negative values for the omega, it will give you the same value of x omega. Why? Because x of omega is an even function, like that's pi over 4. If you have negative pi over 4, so you'll have the value here 24 over pi. Pi over 2, make it negative pi over 2, you have 0. 3 pi over 4, you have -8, you have -8 over pi. Negative pi will be equal to 0. So let's sketch this one. So that's omega, and that's x omega. Start from 0. I think we're doing omega changing every pi over 4. So have pi over 4, pi over 2, pi over 2, and then you have 3 pi over 4, and you have pi. We can continue, but just let's focus on this one. The top here at 0 was equal to 12. And then at pi over 4, we'll have 24 over pi, and then go on pi over 2 be 0. So it will be 0 here. So it's decreasing. And you can adjust the curve, because you know when it's pi over 4, the value is equal to 24 over pi. Again, it will be 0 at pi, so it will go like that. The value is negative 3 pi over 4. If you remember, it's equal to negative 8 over pi. And you observe it's decreasing. So I expect when you go here, it will be the value decreasing every time, decreasing till it goes to 0. And if the negative part will be symmetric. So if you have negative pi over 2, it will be 0. So it will be symmetric like this value here. So, and it'll be 0 here again, the same value. We're going to sketch just the same value, negative 8 over pi, and decreasing the same thing. So this will be the x of omega. And you observe here, it can give you the amplitude of x of omega at every single value of omega choose, not discrete. It's a continuous. So the spectrum here is continuous, different than Fourier series. Fourier series, if you remember, it was like discrete values at certain omega, like 1 omega naught, 2 omega naught, 3 omega naught. But in this case, no. You have the frequency for every single value of omega you choose. It's a continuous. And observe, it's symmetric about the y-axis. But what about the magnitude spectrum? Magnitude spectrum, it means you want to sketch the relationship between omega and the magnitude of x omega. What does it mean? It means you just keep the value and don't put the sign or the angle. So let's just do that. I'm going to do it on the same curve. I'm just going to choose different color. This one, it's okay because it's magnitude only, that's fine. But when you go there, it's negative. So when you take the absolute value, for example, this value, when you say negative 8 over pi, the absolute value is equal 8 over pi positive. So this part is going to be reflected. We'll take the positive value. And this one is positive value, it's okay. And this one you reflected. So that will be, and the same thing will be here. So the curve will be like that. So if you want to sketch it on its own graph, so the magnitude spectrum will look like that. And the same thing will be here. I observe every time that the magnitude is decreasing. That's x of omega, the absolute value or the magnitude, and that's omega. Well, what about the angle? Well, the angle, it's simple here because you don't have a imaginary part, but in x of omega, you either have positive or negative. In this case, when you have a positive value, it means the angle is equal 0. Let me write it. The angle, I mean the angle of x of omega. If the value is negative, so the angle of x omega, not equal 0 like that one, will be equal to 180 degrees, or we can say pi. So let's see how we sketch the angle. That's omega, and that's the angle. Sometimes we write the angle like that, the argument of x of omega, the same thing. You can write it like that or that. Okay, so we observe that the original one, that was positive value from 0 up to pi over 2 is 0. So up to pi over 2 is 0. So you just make it 0. The angle is equal to 0. And from pi over 2 to pi, it was negative. So the angle will be equal to pi. So if you can, pi, so that's, I mean, you can make it like that. That's pi. And then this one will be 0, again pi. So you can do it like that. It will be symmetric on the other side also. So that will be the phase of the, that's called the phase spectrum. Let me just write, this is the value pi, and this is 0. Phase spectrum. And what we did in the top, magnitude spectrum. Both plots together, they call it line spectra. So line spectra include both magnitude spectrum and phase spectrum. Magnitude spectrum, it means the absolute value of x omega against omega, and this one, the angle of x omega against omega. There is something interesting I want just to mention here by chance, is how can you express the result we got as a sinc function? What? Sinc function. That's what we got. This value got 12 sine 2 omega over 2 omega. Let me write the result here. That's what we got. X of omega is equal 12 sine 2 omega over 2 omega. We can express this as sinc function. What is sinc function? Well, we have two definitions. Sine t, or doesn't have to be time, sine any variable like say sine, well, let's say sine q over q. That's not sinc function. Sometimes they call it sinc, but they call it unnormalized. Unnormalized sinc function. Another name, they call it sample function, SA function of q. If it's normalized, it will look like that. Sine pi q over pi q, that's called sinc function. That's the first, we call it normalized sinc function. How you write it? Sinc q. So sinc q equal to sine pi q over pi q. And the graph of sinc q very similar to what we did here, x of omega. That's what we call it sinc. Okay, when it's normalized, that's important that you know. That's used in digital processing. But sine q over q unnormalized, doesn't have the pi as you see, we call it sample function, SA of q. Well, so what do we have here? Can we express this as sinc? Yes, of course. I'll write it like that. X of omega is equal to 12 sine 2 omega over 2 omega. I want to make it a sinc, but as you know, sinc, it has pi. So just we'll do a little trick. We'll say it's equal sine. I will say 2 omega, I want to have pi. because this is the original. And if multiply by pi, divide this by pi, right? The same thing we're going to do in the bottom. We have 2 omega, who multiply by pi over pi. You see, so the top, like the bottom, but it has the pi to be normalized. So actually, this is your q. 2 omega over pi over q. And remember, when you say sine pi q over pi q, it's equal sin q. So how you write this one? But by the way, you made it change. Why? Because you divided by pi, multiply by, no, there's no change, nothing. Because I mean, that's originally I have 2 omega, I divide by pi, multiply by, no change. So what do you have? You have 12, and this is how you write it. 2 omega over pi is our q, like when you compare it, this is our q. So we'll say 12 sin, our new q is equal to 2 omega over pi. So that's how we express the Fourier transform of rectangular pulse in sinc function. That's the meaning of sinc, how you write it, the normalized sinc. Another thing, not every function you will be given, you have to do the integration. They already made it easy for us, and they made a table, and this table, you have it in the folio system. It's called Fourier Transform pairs. What does it mean? They give you in this table, if you look at it, it'll give you the function on time domain and the corresponding omega. So you don't have to find the integration. So what's your job to do? You got to adjust the formula according to the signal that you have. Now let me get the table and tell you what is the expression of Fourier transform of this function that we have in the table. In the table, of course, they give you the standard one. So when you look at the table that you have, they write like that: rectangular pulse t over tau. The Fourier transform will be equal to tau sinc omega tau over 2 pi. That's given in the table. Given in the table that Fourier transform pairs. Well, I want to check. To check, you go back to the function that you try to find Fourier transform, that you in the beginning here of the problem. It was x of t, actually rectangular t over 4, the amplitude is equal 1, but in this case the amplitude is equal 3. You should write 3 in the front here, because the standard rectangular pulse has amplitude equal to 1. If the amplitude is different, you just put it in the front here. Well, so our function is 3 rectangular t over 4. So let me write the function that we have in our hand. In our case, we have 3 rectangle t over 4. So when you compare, focus on this one. That's exactly what you have in the table. So you have tau equal to 4. If you do that, tau is equal to 4, and you got sinc omega tau is equal to 4 over 2 pi. And then you got the 3, multiply the 3 here. So let's simplify. 3 times 4 is equal to 12, sinc, and then you got 2, and you got 4. You can simplify if you wish. By 2 is equal 1, by 2 is equal 2, it will be 2 omega over pi. So that will be the answer. You see, I didn't do an integration, I just used a table. What did we get when we did the integration? 12 sinc 2 omega over pi. 12 sinc 2 omega over pi. It's the same result. So this example is good for how to use the integral form to find Fourier transform, and also how to use the table and adjust it. Thank you, and I hope that you got it.